Let's draw it. Because the order of the letters is important.
Mm-hmm.
If that's E, D, I, and that's W, U, F, and they are similar, angle D have to be equal to angle U?
Yes.
DIE equal to FW or WFU?
Yes.
And E equal to W?
Yes.
D equal to W.
No.
All right. Kind of knew that was the correct answer by the time we got to it, huh?
Mm-hmm.
Okay. Number 22. This is the one that has to do with linear, excuse me, linear ratios, area ratios, and volume ratios. Let's say the linear ratio was 1 to 2. What would the area ratio be?
1 to 4.
What would the volume ratio be?
1 to 8.
All right. So that's the relationship. In other words, the area ratio is the square of the linear. Volume is the cube of the linear. So they're saying that the area ratio is 4 to 49. Let me erase these other numbers because these were just numbers I made up to make sure you knew the thing. So if the area ratio is 4 to 49, how do I get the volume ratio?
Square root it.
What's that?
You square root it.
That'd give me the linear ratio.
Oh.
In other words, to go from the area ratio to the volume ratio is not quite so easy. There's two ways to do it. Really the easiest way to do it is to go back to the linear ratio. What's the linear ratio?
2 to 7.
Now you can go directly from the linear ratio to the volume ratio. What's the volume ratio?
8 to 3, 4, 3.
Which is 7 cubed. In other words, that's 2 cubed, that's 7 cubed. So notice that the easiest way was to go backwards first and then forward. There is another way to do this. You can just take that and take it to the 3 halves. But that probably confuses people more than helps them. So I would say always do the easiest step first here, which is to go back to the linear ratio, and then you can get from linear to volume pretty easily, right? All right. The primary difference between two shapes that are similar but not congruent is their IQ. I like that.
Their size?
Yes. In other words, those are similar, but they're not congruent. Their angles are all the same. That angle's the same as that. That angle's the same as that. And that angle's the same as that. So that's what makes them similar. So it's not their angles. Their shape is exactly the same. The only thing that's different is their size.
Mm-hmm.
Perhaps their IQ.
Mm-hmm.
Being funny.
Mm-hmm.
Trying to be. All right. So solve this. Tell me every step.
You would cross multiply.
What do you get?
12x equals 34 times 5.
Which is 270.
And then you divide 12
Okay.
by each side.
What number? Is that a, I don't think it's a round number.
It's 22.5, or 22.5.
Okay. The first step here.
Cross multiply.
Notice that cross multiplying is actually a little self-defeating here. In other words, I can multiply both sides by 4 and both sides by 20, which is what cross multiplication is. But how if I just multiply each side by 20? Is that not easier? And then you can do this and you get 85. Notice that if I do cross multiply, I now have to divide both sides by what I just multiplied both sides by. So the fact cross multiplication is nothing but multiplying by this denominator and then multiplying by that denominator. Okay. Well, it seems kind of silly to have to multiply 4 times x and then divide both sides by 4, right? That's an extra step. So be wary, and that'll save you a step if you remember. If your variable is in the numerator, you don't actually need to cross multiply. You just need to get rid of that denominator, which is 20. You see the difference?
Mm-hmm.
It's not as easy to do that with 24. In fact, we can't do it. 24 does require us to cross multiply and then divide by 12. But 25 does not. 25 is actually easier if you only multiply both sides by 20.
Good.
First step.
Could you do what we did on 25 with 26 then?
Very good. So what's the first step?
So you would do x equals...
Well, let's do it one step at a time. In other words, we don't actually need to cross multiply, do we?
No.
But we need to get rid of that 9.
Yeah.
So the first step is to multiply both sides by 9. Now what can I do on the right? What's that all equal to?
It would be... It would equal 6.
Okay. Now I got 2x minus 3 equals 6. What's the next step?
You would add 3 to both sides.
So now now I have 2x equals 9. Now that means x equals 4.5. Same thing. Because my variable was in the numerator, it would have been counterproductive to cross multiply, because I would have had to multiply that by 3 and then just very next step divided it by 3. So why do both of those things? In other words, Our goal is to isolate the x, so all we really need to do is get rid of that denominator. Now in this one, we've got, I love this part of geometry where they go over and they review algebra, because that's what this is.
Mm-hmm.
This is not geometry. But
No.
that's good because you've gone quite a while without really reviewing algebra. And algebra is a big part of geometry. So what's the first step here?
For this one, would you cross multiply?
I think so. If I have a variable in the bottom, just automatically cross multiply. It actually might be a little more efficient if I just multiplied the top by this, but actually not, because I end up with a fraction. So cross multiplying is correct here. 8x plus 10 equals 7x minus 42. The next step?
You would minus 7 from both sides. Minus 7x from both sides.
So, and then also at the same time, move the 10 over.
No.
This is the one time where I think it's okay to do two steps in one.
Mm-hmm.
In other words, because the philosophy here is I'm going to move all my variables to the left, I'm going to move all my numbers to the right. So let's just do it in one step.
Okay.
Okay, and I don't think there's, you know, increased chances of mistakes or anything doing it that way. $28. Give me a ratio that'll allow me to solve for m.
You could do I have no clue.
Take
Would you do
individual triangles. In other words, make your ratio 9 to 12, 9 centimeters to 12 meters. Notice the different units. Equals what?
m over 20?
M centimeters over 20 meters. Now what does m have to be? Let's see, if we cross multiply, m ends up being 15. 9 is 3/4 of 12, 15 is 3/4 of 20.
Okay.
Okay, and the way to handle the units problem here, it's not really a problem. In other words, if I cross multiply, I get that. I get m equals 15. And I can tell by that that m has to be in centimeters. Because on the left, you got centimeters to meters. On the right, you have to have centimeters to meters. Number 29. I want you to solve for n and o.
So, should I solve for n first then?
Yeah, you can definitely solve for n. What's the relationship between the small triangle and the big triangle? Not the little trapezoid here, but the big triangle. What's the relationship?
They have parallel sides.
Are they congruent? Are they similar?
They're similar.
That's the key. So now give me a ratio, because similar triangles will always produce ratios. And sometimes it's quite helpful if you separate out the figures. That's one triangle. That's the other triangle. So give me a ratio if they're similar. N is to what as what is to what?
N is to 6, or N over 6 is...
I'm a little uncomfortable with that. That actually might be right, but I don't think it is. In other words, remember with similar triangles. Let me back up a step here, or go forward a step. There's two things that happen with similar triangles. It might not be readily apparent at first. So let me remind you. These two triangles are similar, right?
Mm-hmm.
Well, there's all kinds of ratios that are true. I can say 5 is to 10 as 4 is to 8. See how I got that?
Mm-hmm.
That's corresponding sides of each triangle. But I can also say 4 is to 5 as 8 is to 10. In other words, this side relative to the same side, not the same side, but the side in the same triangle is the same ratio as that corresponding side is to its corresponding. So these ratios, there's all kinds of them that are true when you have similar triangles. And in other words, you can relate sides of one triangle to the side of another, or you can relate side of one triangle to a side of the same triangle. Those relationships are the same regardless.
Okay.
And it's important to see that. Hold on a moment. So, these two triangles, hold on a minute. So, relate same sides. In other words, if I said n is to 18, what else can I say? What's the big triangle? What's this measurement right here?
N plus 6.
Uh-huh. And what's this measurement over here?
18. What?
18 plus 4, right?
Yeah.
Okay, now give me this side. Give me that relationship.
It would be N plus 6 is over 22.
Yeah. In other words, the easiest way that I saw to solve this problem, there's probably multiple ways, but the easiest way is to set up the relationship. In other words, set it up, the relationship within this smaller triangle has to be the same as the relationship of those same two sides in the bigger triangle. And so you end up with that. And now you can always solve that by cross-multiplying. Go ahead and cross-multiply that. I have circled, solve that for n.
N would be...
Well, step by step.
Oh, so it would be 22 n equals 18n plus 108.
So you got 4n equals 108, n equals 27. Now, we can also use that same ratio to solve for O, right?
Mm-hmm.
That's the beauty about being able to do it multiple ways. This is that I really only had 2 steps to solve for both n and O. In other words, I solved for n rather easily. Now give me a relationship to solve for O.
You could do 18 is to O, or like O over 18 is 22 over 30.
Okay, boy, you almost were perfect there. I love the fact that you put O in the numerator, because that means we're going to save a step. We don't have to cross multiply. But if I'm going to put O in the numerator, it's O is to 18 as 30 is to 22. You make sure you put the ratios of these correct sides. In other words, 30 is the corresponding side to O, as 22 is to 18. So I also could have said, notice, I could have said O is to 30 as 18 is to 22. Well, that's bizarre. In other words, in the second case, I related that to start with, and that has to be the same as that to that. Well, notice what happens. When I cross multiply, in the first case, I get 22O equals 540, and in the second case, I get 22O equals 540. Even though I started with a completely different method. In the first case, I related O to the another side of the same triangle, and in the second case, I related O to the corresponding side of the other triangle. But it produced the same results. And that's the nature of similar triangles. Always remember that these relationships are just about any relationship that relates sides within the same triangle to the same sides within the similar triangle, or one side of the smaller triangle related to the same corresponding side of the bigger triangle. You can do it either way, and whichever one is easier, you do it that way. But either case, O is equal to, man, is there one variable that's worse than O? I can't think of one. You see why? Because it's...
Yeah, it looks like a 0.
Like 0, yeah. And it's not, it's a letter, O.
Yeah.
Whatever that number is.
It's 24.54 repeating.
Both repeating or just the 4?
Both 54.
Okay. The most important thing on 29 is recognizing that you're dealing with similar triangles. The mistake that you might make here is trying to compare this similar triangle with this trapezoid. Let's see what happens there. I'm not sure that's actually a deadly mistake. It might actually work. In other words, is n to 6 equal to 18 to 4? Gosh, I'm not sure. Yes, it is, isn't it? That would have been far simpler.
It would have been, but it may not be true for all the other ones.
Well, I don't know. I'm a little uncomfortable when I start comparing sides of a triangle to sides of a trapezoid, because that's what this lower figure is a trapezoid. So I don't know that theorems back that up. They apparently do. But what I know for sure is similar triangles. And because these two lines are parallel, I know that this top triangle is similar to the big triangle. And that's what I feel most comfortable with making my ratios, is similar triangles. But I've come across this before, and I've noticed this, and a lot of people want to do it that way. They want to say n is to 6 as 18 is to 4, and I'm always a little hesitant to whether that's true or not. I guess it is true.
Yeah.
All right. It's 4, Allie. I'm going to let you go. I got appointments back to back to back to back today. I will talk to you Thursday at 4, I believe, correct?
I think so, yes.
Just check real quick, make sure that's what I got. Yeah, Thursday at 4. Talk
Okay.
to you then.
Thank you.